Okay, we're live on YouTube. Very good morning to everybody present here with us today. Thank you for joining us virtually. My name is Shruti and I'm the program coordinator for India Science Festival. On behalf of the entire team at ISF, I wish you all a very good morning and I thank you for joining us for yet another day of our month-long virtual festival. India Science Month Online is India's largest virtual science festival and aims at bringing science and society together. We aim to serve as a platform for public engagement, wherein we bring together researchers, um, speakers, scientists, educators, students, and teachers from all across the world to celebrate science and technology on one platform. Um, I think I've mentioned before in my introductions that our festival has a lot of events. We have talks, panel discussions, workshops, demonstrations, very fun science games, and so on in order to make science more engaging and fun for everybody. We have put together various events based on the topics of space, health, robotics, general science, and science communication. And we are very excited about the weeks to come. We have events going on till the 31st of January. So, in case you haven't checked out our events yet, make sure you head over to our website and take a good look at all the events that we have planned for everybody. We also have a lot of Twitter contests going on. So we would recommend that everybody checks out our social media handles because we're very active on LinkedIn, Twitter, Facebook, and Instagram. Make sure that you tell us what you think about our workshops, of about our talks, about our discussions. Take a screen grab of your favorite talk, put it up on Twitter, tag us, and tell us what you liked most about the session. Today we are going to be having a very interesting 3 hour session for researchers, mainly those who are doing their master's, PhD, and they are in their postdoc, and we are going to talk about some very important issues that researchers face. And we have with us a very capable team of trainers who are going to take us through the workshop. This workshop is brought to everybody by our knowledge partners, our upskill is the researcher education brand of Cactus Communications and is deeply committed to help scholars break through the confines of geography and language to accelerate the process of publishing high quality research. This workshop is something that is a must for all researchers out there, and I can assure you that at the end of this session, you are going to feel a lot more skilled. Our upskill courses cater to both kinds of learning requirements: immersive deep diving into important topics to attain mastery, and quick learning through short courses that address specific pain points. So, what do we have lined up for you today? We have three sessions, each session lasting for an hour, wherein our speaker or our academic trainer will be talking to us for around 40 minutes, following which we will be taking questions from all our audience members. So make sure that you leave your questions in the Q&A box and our trainer will answer them for you. Let me introduce the first academic trainer that we have, who's going to talk about publishing, getting your research papers published, and how to deal with rejection and what you can do to make things right for the next time. So, if I could please request Dr. Jacob Wickham, who is a renowned and celebrated zoologist, has over 15 years of experience in academic publishing, and has published several papers in high impact journals. Dr. Wickham has gained a lot of valuable experience in research and journal publishing over the years, and is passionate about sharing his knowledge with researchers to help them in their publication journey. Dr. Wickham, thank you so much for joining us. It's such a pleasure to have you here. And I'm sure that
Hi.
our attendees are very, very excited about listening to what you have prepared for all of us. So, if I could just request you to take it ahead from there. But before we actually begin with this session, I'd just like our attendees to answer a quick poll for all of us so that we know the background that everybody belongs to. So if you could just answer the poll that is in front of you. Okay, so our results tell us that we have a few faculty members, some professionals working in the field, most of our attendees are in their PhD or their postdoc. So that is definitely helpful, and I'd just like to know a little more about the background uh, of all our attendees. So if you could just answer this poll for me. Okay, so the poll results tell us that our attendees don't know much about the topic but are curious to know more. Some of them are working professionals in the field and are curious to know more. So I think that gives us a fair idea about the background of our attendees. Dr. Wickham, over to you.
Okay, thank you, Chitri, for the great introduction. I'm going to be sharing my screen. And our first of the 2 hours of webinars is going to be on the topic of publishing. And one of the common hurdles that you will face when you're publishing your papers is dealing with rejection of your paper. And I'll give you some tips on how to overcome journal rejection. And actually, I've been a journal editor for about 7 years now. So I can tell you a lot of what happens behind the scenes when we're evaluating manuscripts for publication. But being a journal editor is just a part-time job for me. My full-time job is I am a researcher. I'm an entomologist. I study insects, and I've been working in China and the United States for the past 10 years. So what will you gain from this short course? Hopefully you'll have a better understanding of how to get papers accepted, how to handle rejection, what parameters are considered in papers, what makes a paper flourish, what causes them to get rejected, what to do when your papers are rejected, and how to go about rebuttal. This could be your rebuttal letter when you reply to the reviewers and the editors' suggestions or comments on your manuscript. So I'll give you some tips on how to reply to them and increase your chances of getting your papers accepted, which is the end goal for a lot of your research. And finally, I'll go into how you can go about writing a perfect thesis, and that looks like a complete package. So many of you are still working on your master's and PhDs, so that will be useful for you. So here's my background. I am the managing editor of Integrative Zoology, and I've been the senior editor since 2017. So I participate in a lot of the screening of the manuscripts when they get submitted to the journal, and reject the manuscripts when they're submitted to make sure they fit the journal scope. I'm also an assistant professor in the Institute of Zoology, Chinese Academy of Sciences, and I have an adjunct professorship at Rutgers University in the United States. So here's a brief overview of today's part one of the webinar. I'll go over the peer review process, general and language-related causes of rejection, commonly cited reasons in rejection letters. I'll give you some sample rejection letters and how to process them. Sometimes it's difficult to understand reviewers' comments. They might seem a bit vague and you may not understand them, so I'll help you decipher reviewers' comments. And finally, I'll give you some tips on how to overcome journal rejection and avoid rejection altogether and get your papers published in the shortest period of time possible. So what do journals want? Basically, this is a little schematic of what journals really care about. Journals care a lot about impact factor. Most journals are also looking for original work. They want novelty. And basically, Integrative Zoology, since the journal was founded in 2006, 2010 was the first year we got an impact factor. And if I add on a couple more years, we actually increased up to 2.5 for our impact factor, and we are now rated in the top 10% of all the zoology journals worldwide. And to achieve this, we are selecting the best manuscripts that we think will be cited the most by other journals. And if you're not familiar with impact factor, it's basically a measure of citations to that journal to papers published in the previous 2 years. So the 2019 impact factor looks at citations to that journal in 2018 and 2017. So they put citations in the numerator and then put the number of articles published in the denominator, and that quotient gives you the impact factor. There's a lot of other metrics to measure journal performance. Some of the ones that you should be looking at is maybe journal turnaround time. You don't want your paper stuck in peer review or go through the cycle of rejection and resubmission for years on end, which sometimes happens. Most journals, if you look on their home page, you can get information about their turnaround time because we're all competing for your manuscripts. We want high quality manuscripts that are concise, well written, and if journal takes way too long to make decisions, that reflects badly on the journal. So actually we are competing with the other journals. We want to serve you, the authors, the best we can. So the traditional peer review process, basically the author submits to the journal, or it might be a resubmission. There's editorial screening that happens in the editorial office. A common result is rejection without review. That might be a mismatch with the journal scope, but if it does get through peer review, Basically the decision recommendations from the reviewers will come back to the editor, and then the editor will make a decision, either a rejection or revision. And usually it goes through a couple cycles of revision before it gets accepted. Because we want to keep the time from submission to final decision as short a time as possible, if the authors do a great job revising the manuscript, after you resubmit it, frequently we will not send it out for peer review again. The editor can check to make sure you made the appropriate revisions, and we can editorially accept the paper. There's been a huge burden on peer reviewers this past year. For example, at Integrative Zoology, we had a 300% submission increase during the COVID-19 pandemic. So I think a lot of the authors are clearing their backlog of manuscripts. They have a lot more time now to write up results from previous research. So although research might have been slowed during the pandemic, there's been a big flurry of manuscript submissions. And I think that's happened the world over with all the journals. And here's the peer review process at Integrative Zoology. Inside the editorial office, we have a lot of experts. A senior editor will often be asked to look at a manuscript, and we typically reject about 60% of all the manuscripts during this initial screening phase. So then the manuscripts will get, because I'm not an expert in everything, sometimes I'll ask an associate editor or a subject editor to also look at the research to see if it's sound, and then we'll send that out for peer review. The number of peer reviewers that we get varies. We get usually a minimum of 2 peer reviewers are sought. Once it's sent out for peer review, if you get it through the first process and you're not rejected without review, you should pat yourself on the back because more than half of the manuscripts are rejected at that stage. So if you actually get it sent out for peer review, you have a greater than 50% chance of getting the manuscript accepted. So we introduced this pre-review step in 2016. It basically doubled our reject without review rates, but of the manuscripts that got sent out for peer review, most of them got accepted. So we saved the author's time and also the reviewer's time, because we're not asking them to review poor quality manuscripts. Only the best quality manuscripts are getting through. There's many different types of peer review. There's a single blind. That's the most typical format that's used, where the authors cannot identify who the reviewers are. Integrative Zoology actually uses double blind peer review. So we do not include the author's information with the manuscript, and we do not include the acknowledgements, because that's another way to find out who the authors are. So we just give the title, abstract, and the manuscript and send that out for peer review. And that tends to be a lot more fair. A lot of the Nature family of journals, they now give you the option of selecting double-blind peer review. And the triple-blind peer review is even the editors have no idea who the reviewers are. So that's it's almost like a drug trial where the patients and the doctors and nobody knows except the person designing the experiment who's participating in the process. There's also been a trend for open peer review. A lot of the frontiers journals now have open peer review. And that means that the reviewers' names will actually be published alongside the editor's name and the reviewer's name and the author's names on the manuscripts following publication. So there is a bigger trend for open peer review. And then, of course, after your publication is out, it's open peer review because it's reader evaluated. So pre-publication is pre-submission review, and then post-publication review is basically the feedback you get from the scientific community. So peer review is the backbone of academic publishing. Basically, reviewers do this for free. They give up their time to improve science in their field. Peer reviewers are asked to comment on novelty of the research, trustworthiness of the science, and the overall presentation of the article. Peer review reports will help guide decisions of journal editors. Peer reviewers, they cannot make decisions. They can only make recommendations. It's the journal editors that make decisions. So if you have any conflicts with any reviewers, it's probably good to approach a journal editor and notify them that you think there's a conflict of interest. So don't worry if a reviewer is particularly harsh. You can just respond to that reviewer point by point, and the journal editor will see that you are trying to do that in a professional way. So remember, it's the journal editors that make the decisions, not the peer reviewers. So standards of review may vary according to the field, publisher, and journal publication medium. And most journals will have a minimum of 2 reviewers, but more is also common. I usually try to get 3 reviewers to review a manuscript because sometimes one is really late, especially in the COVID pandemic time period. It's difficult to get reviewers, or maybe one review is just a poor quality review and it doesn't help me make a decision. So usually if I get 3 reviewers to agree to review, I'll have 2 solid reviews from which to make a decision. You have to be careful. There's cases of fake reviewers. There's a retraction watch, and this is a growing problem in academia. And basically, this scientist made up fake email accounts so he can do his own peer review. And he did that for 35 of his papers. And this is a pretty bad problem. To overcome this problem, usually I'll be selecting reviewers that have official email addresses. So if you have a university or institutional email account, I would suggest you use that when you're doing peer review or suggesting peer reviewers. So be careful of Hotmail and Yahoo accounts. So these are cases of fake reviewers. There's been a lot of retractions in China as well. There's over 100 retractions based on fake peer review. So what happened here? Journals usually ask for suggested reviewers. This is very common. And you can make some suggestions. And in this case, the authors gave false identities for themselves or colleagues, or names of real people with false email addresses controlled by the author or their associates. And the articles were reviewed by these recommended reviewers, and these are authors posing as reviewers, and the reviews came back fast and positive. And usually I don't get all 3 reviewers to like a paper. If even the 3rd reviewer likes the paper, I'll get suspicious. So at Integrative Zoology, usually we ask authors to recommend up to 4 reviewers, and to have an unbiased peer review as possible. We only use reviewers that provide official academic email addresses, and we'll only use 1 at the most of the author recommended reviewers. And we do not use reviewers from the same country as that of the authors, or a maximum of only 1 reviewer. So if we have a submission from China, we will only use at the maximum 1 reviewer from China. And here's a controversial question. Is peer reviewed flawed? And are non-native speakers given a fair shot? And there's a nice article online here that looks at peer review, and they examined about 5,000 papers submitted to biological conservation. This journal, they usually give 2 to 4 weeks for a review, and then 2 to 3 reviewers are generally assigned. This is a single blind peer review. Again, at Integrative Zoology, we use double blind. So here is a graphic about when you get 2 reviews that come back on your manuscript. This is the probability of acceptance. So if you have minor revisions by both authors, you have almost 90-95% chance of acceptance. Even if you have major revisions recommended by both authors, you have a greater than 50% chance of probability of acceptance. Or if you have at least one recommendation of accept or minor revisions, you have a greater than 75% chance of getting your paper accepted. But if one of them recommends reject, it doesn't necessarily kill the paper, but it really decreases your chances of acceptance. So that's an interesting graphic. Rarely is there agreement between two reviewers. I found that out as an editor. And then we looked at English-speaking countries versus China. And this is comparison of reviewer recommendations for received for articles from English-speaking countries to that of China. And as you can see, the English-speaking countries, they have a greater proportion of the manuscripts are asked to have minor revisions, where there's a smaller percentage asked to give major revisions. So typically, if you're a non-native speaker, there may be some more problems with the language and expression, but the overall acceptance rates are pretty comparable. So after considering these papers that were submitted over 7 years to this journal, the acceptance rates from English-speaking countries is only 10% higher than papers from China. So it's 51% versus 42%. And for Chinese authors, the rejection rate from UK-based reviewers is only 15%. And the rejection rate from that of China-based reviewers was 43%. So there's actually harsh reviewers from China. The UK reviewers were actually very gentle to the Chinese authors. So if you consider all these decisions, basically papers from China have a rejection without review rate of 71%. Well, including rejection without review, is 71% compared to 50% from English-speaking countries. So in the end, you have a 25% acceptance rate from English-speaking countries, and where those from China have a 12% acceptance rate. So there is a big hurdle for non-native speakers. So here's rejection in numbers, just worldwide. So there's about 4 million scholarly papers published annually. 21% of these articles face rejection after editorial screening. 40% face rejection after peer review. And if you submit to a really high-end journal, the rejection rates are about 90%. And that translates to a 5 to 10% acceptance rate after review. So comparatively, integrative zoology, our rejection rate's about 70%. But now that we've done the editorial screening, we have a greater than 50% chance of being accepted after review. But in general, there's been a huge increase in the number of submissions to journals worldwide, and we have seen a 10-fold increase in rejection rates over the past decade. So another good question is peer review important? I believe it's the gold standard of science. It's designed to be objective and as fair as possible. And basically, it's quality control for the journals. And the peer reviewers will give us enough information, meaning the editors, enough information to make a decision on the paper and whether the paper is trustworthy. And having gone through the peer review process, a panel of experts has critically looked at the paper, and typically the goal is to improve the paper. And I've seen some okay papers turned into excellent pieces of work having gone through the peer review process. So most scientists think that peer review is essential for controlling the quality of science communication. And 32% think that this is the current system is the best achievable one. So there are a lot of different forms of peer review. So you have single blind, double blind, and open peer review. You can now do preprints. There's a RXIV. You can actually upload your paper before you send it out for peer review. And so that you can, there's preprint servers that you can use. And actually that gets your information out there into the public's eye. And a lot of journals like Nature and Science, they're interested to know if you have uploaded your document, your manuscript to a preprint server. So now I'll go over some causes of rejection. After your manuscript is submitted, it'll undergo some editorial screening in the editorial office. So we'll check for plagiarism. We'll look to see if it's a resubmission of previous published work. Maybe the article repeats or confirms previously published data. That may be not, your manuscript may not have enough novelty if it's a resubmission of published work. We check to see if there's a title overlap to previously submitted papers at the journal too. And that'll be a red flag if your title overlaps. You may have insufficient data or evidence or incomplete results. And one of the most common reasons for rejection is nonconformity to journal guidelines and scope. So carefully check the scope and guidelines of the journal before you submit, because that's pretty much one of the most common reasons for rejection. The plagiarism checks. This slide goes over what I will see after I submit a journal to iAuthenticate. Basically, I'll get a report and you'll get a percent text overlap result. And this is a similarity index. And most journals will have an upper limit to how high this can be. If there's too much text overlap, frequently we will send the manuscript back to the authors and we'll ask you to try to change some of the wording and put more of the manuscript into your own words. Because if you copy and paste from a manuscript or even from an internet resource, you can see the first 3 hits on this is text overlap from internet sources. Typically, Nature and Science, they set their limits at about 15%, and integrative zoology, our maximum is about 25 to 30% text overlap. If it's higher than that, we'll send it back to the authors. If this is a problem, you may want to ask the journal editors to send the report that I get. It's a PDF, and it'll actually show every word that has overlap with previously published papers and internet content. Another cause of rejection is during peer review. The peer reviewers may note that there's low significance of the study or insufficient data and evidence for validation. It might lack novelty. You might just have incremental data. Some other journals don't care about novelty. So if you do have a study that's like a confirmation study, or it's the result was shown in one system and you repeated it in another system, you may want to try +1 or scientific reports. They do not care about novelty. But most journals, they do want to publish novel manuscripts. A lot of the causes for rejection may be language related causes. You may have unclear explanation of the title or research hypotheses and or results. You may use non-academic or colloquial language. The content of the manuscript may be difficult to comprehend. There may be a lot of misspellings or typographical errors. Don't forget to do spell check before you submit it. Actually, Grammarly can check the grammar for free online. I know a lot of professors in China, they ask their students to run their manuscripts through Grammarly. You can also use the help of Editage. They specialize in editing manuscripts before submissions to journals. Again, you want to be consistent with using the tense and voice, and this will avoid misinterpretation of data. and do not use redundant expressions. There's an example of bad writing in red and then edited writing in green. So other language-related causes may be inconsistent tone and tenses. There's an example of poor writing in red and then a better constructed sentence. You want to have the singular and plural agreement. Studies is plural, so you want to use the verb were instead of are. You want to use proper past tense. You want to use appropriate word choice and phrases instead of at the other hand. You say on the other hand. I have been curious about variety fields. That's incorrect. You want to say I have been curious about various fields. And you don't want to use contractions. And also avoid using acronyms and scientific jargon. You will want to define acronyms in your manuscript, especially when you first use it. Make sure you use the active or passive voice consistently. Typically in the method sections, you'll use, you can use the active voice or you can use passive past tense. Like the data were analyzed. And make sure you have subject verb agreement. If you have subject verb disagreement, that reflects badly in the writing. So make sure that the subject and verb agree in one another in person and number. If the subject is in plural form, make sure the verb is also in the plural form. Like data is plural, so you want to say these data were analyzed. And you want to use proper pronouns. Use he or she or him and her instead of using they when the gender is known and they when it is unknown. You want to use the correct use of articles, a or an in your subject writing. This is a common problem with a lot of Chinese papers. And you want to use, in regards to initialisms, use the definite article, like the UN General Assembly was established in 1945. And if the initialism is talking about a notion in general, then do not use an article. So there's no articles in this sentence. So Intel provides cache monitoring technology that can monitor the cache usage of tasks. Okay, now to get into rejection letters. I'll give you some sample rejection letters. This one is from Nature. You can see in the highlighted note here, while they find your work of some potential interest, they have raised concerns in which they view your work, While they find your work of some potential interest, they have raised concerns which, in our view, are insufficient importance that they preclude publication of the work in Nature, at least in its present form. Should further experimental data allow you to address these criticisms, we would be happy to look at a revised manuscript. So basically this one is a soft rejection. So they find some flaws in your work in its present form, and they say they'll be happy if you provide additional data to look at a revised manuscript. So this is a soft rejection. Here's another rejection letter. I'll highlight the yellow there. Your topic is certainly of appropriate scope for science, and your analysis is interesting. However, following discussion among the editors and members of our board of reviewing advisors, it was given a lower priority ranking than others. So this was a reject without review. So it's interesting, it fits the scope, but we're sorry to have to disappoint you in this instance, and we wish you the best of luck in publishing your work elsewhere. This is actually not even sent out for peer review. Even if your manuscript is given a very good peer review, some of the top journals are extremely selective in the manuscripts. And they said, despite the good peer reviews, we're still rejecting your manuscript because we will only publish manuscripts that attract the highest support for publication. So these are, there's nothing wrong with your paper. It's the journals that are just being very nitpicky and just selecting the best papers. And here's another rejection letter. I'll highlight the yellow here. You'll see that while they find your work of some potential interest, our referees raise concerns about the degree of novel insight into the strength of the novel conclusions that can be drawn at this stage. So they regret they can't publish it in Nature, but you may publish it in another journal in the Nature publishing group. So they'll actually give you an opportunity to transfer your article. So they like your work, they'll reject it from Nature, but they may find it appropriate to publish in another journal. So they want to keep your paper within the Nature family of journals. So this is a rejection with an offer to transfer your paper. And actually, you'll get the reviews back and you can respond to the reviewers and then submit it to a new journal within the Nature publishing group. So sometimes those can be taken advantage of, and they can save you a lot of time just by submitting it to another journal within the Nature publishing family. Okay, and this is the last rejection letter I'll go over. They highlight here, first, there are numerous technical and scientific issues raised in regard to the interpretation of your studies. However, if you're able to address the reviewer's comments in full with additional data and analysis, we'd be willing to re-review a completely revised manuscript. So if you decide to resubmit your manuscript, please submit a cover letter describing the changes made and addressing the reviewer's comments point by point. So basically this one, they find some problems with it, which is most often the case on an initial submission. I think only 1 in 100 papers will actually get accepted upon the first submission. So here they are asking you to consider revising the manuscript, and they're also asking you, are you willing to provide additional data and do initial data analyses? And if you're willing to do that, then the journal will be willing to review a completely revised manuscript. So this is a revise and resubmit. So here's some common reasons of rejection letters. Basically, probably the most common rejection is not an original study. It's not novel enough. May have not enough significance. Topic might be irrelevant. The methods may be unclear. It may have low readership interest. The international journals want to have a worldwide audience for their papers. Literature review might be outdated. Keep in mind, the impact factors are based on citations to the previous 2 years. So if the literature review has nothing but papers from like 10 years ago, that might be a red flag. So you can also have incorrect conclusions in the paper or just not enough data to support your conclusions. You may have an insufficient discussion of statistical results, or you may have failure to provide sufficient explanation, or you may inconsistently report data or have improper or lack of controls. So be careful to always have proper controls to compare your treatments with in your manuscripts. So what do journal editors actually look for? Journal editors evaluate the overall combination of subject matter, methodology, theory, and contribution to the discipline. So there's no substitute for good ideas, for excellent research, for good, clean writing. So it's good to have a well-written paper that's well-performed and matches the journal's aims and scope, and is a useful contribution to the discipline. So, and these are reasons for rejection given by journal editors. You may pick the wrong journal. You may submit a manuscript with a format that doesn't match what the journal publishes. You may not follow the manuscript preparation instructions. And then items 7 through 4 here are writing issues. So hopefully you can overcome these issues with a good preparation of putting your paper together in a nice, neat way that has all the component parts that the journal is looking for. You don't want to get carried away in the discussion. You don't want to report the results poorly. And you have to have a very good description of the methods because every scientific experiment should be able to be repeated, and there should be sufficient detail so someone who has read your paper can repeat all your experiments. And finally, poor study design, failure to revise and resubmit following peer review. And number 1 surprises me. This is failure to write and submit a full manuscript after presenting the abstract. So that's actually very surprising for me. When you receive a rejection letter, you want to read the content and wait. Put it aside for a day or two and read it again later. Understand what the decision was and the types of rejection, and then respond accordingly. Even if you cannot resubmit to the same journal, the reviewer's comments will help you improve the manuscript for another journal. And don't make the mistake of not addressing the reviewer's concerns, even if you pick a new journal. Frequently, when you do submit to a new journal, the same reviewers may be asked again by the new journal to review your paper. So sometimes you get ambiguous comments in the rejection letter from the reviewers. And this will help you interpret what the real meaning is of the rejection letter. You may have the reviewers say, the paper is not acceptable in its present form. Basically, it suggests that the paper could be accepted after revisions. So you just revise and resubmit. The reviewer may say, the paper did not get a high enough priority. Well, the journal may have reached its annual maximum number of pages of its readership and may not be interested in the paper. So here you'll want to submit the manuscript elsewhere. The reviewer may say, the study is interesting, but too preliminary. So the paper is interesting, but it requires additional data. So here you may want to revise and resubmit as a new article or resubmit elsewhere. They may say, the study is interesting, but is technically flawed. Well, some data may be incomplete and the results may be overinterpreted. So you may overstate your results. So here, it may be possible to revise and resubmit or resubmit elsewhere. Or they may say the work is more appropriate for a specialized journal. A lot of the big journals like Current Biology, Nature, and Science, they want a very broad manuscript. So you may want to submit your manuscript to a more specialized journal that may be a specialty journal in your field. So there you want to submit your manuscript elsewhere. And here's some very vague comments, and I'll tell you the real meaning of them. The reviewer may say the study is descriptive. That basically it says that the paper lists data that do not come together in a clear hypothesis-driven study. Or they may say the study is incremental. The meaning here is the work builds on previous work without contributing any new major concepts. So maybe the advance that you're reporting is too small of an advance. Or they may say that study lacks important controls. And that's a hint that additional experiments are needed for validation. And this is my favorite one. The data are not convincing. I've seen that about 100 times from reviewers. Here, the data are insufficient to validate the main conclusions of the work. It may mean the data quality and statistical significance are inadequate. Maybe you need a larger sample size or better statistical tests. Or the writing style might have obscured the message of the manuscript. So when responding to peer reviewer comments, you want to carefully read and reread the comments. Decide whether you can address the comments in time for resubmission. If you need more time, send an email to the editor. I always give authors extensions, especially in the COVID pandemic time. I know things take a lot of time, communicate with other co-authors. A lot of people are working from home, so it's difficult. When you do respond to peer reviewer comments, you want to group reviews together based on the part of the manuscript they referred to. You can decide whether additional experiments are needed, and you can make a list of changes that are needed, including minor rewriting, language improvement, word count reduction, maybe adding data figures or deleting figures or combining figures together, or additional work in the introduction, discussion, and references. And finally, revising your analysis, like a different model and statistical method. And finally, you can outline your response letter and be sure to respond to all the reviewers' comments. So here's what you do when you agree with the reviewer. You can thank them for your comments. You agree with your suggestion, and you can, in your responding letter, state where you made the changes and list the line numbers where you made the changes. So thank the reviewer, explain why you agreed with them, describe the change you made, and indicate where you made the changes. And when you disagree with the reviewer, it's basically you follow the same format. You thank the reviewer for their comments, you understand their concern, and then make the appropriate changes. But when you disagree with them, make sure that you show that you understood their comment, and then explain why you disagree, and then the changes that you made. And don't forget to indicate in the line numbers where you made the changes. So here's some responses of what you might want to say. You didn't understand what we wrote. So you don't say that. What you should say is some statements that we made were slightly ambiguous, and we have clarified the text. Don't say, hey, that experiment will take forever. What you should say is the suggested experiment is very interesting. However, we feel that it is beyond the scope of our study. Or you may want to just say, you didn't even read what we wrote. So that's not the right way to respond. What you should say is, we did not intend to indicate this, and therefore we clarified the text, altered the text to specify this. Don't tell them they're being too picky about grammar and formatting. You can just say apologize for the errors and say that you have made the suggested changes. So facts about journal rejections. The rejection rate of a journal is the number of rejections divided by the number of submissions. Most journals have rejection rates between 25 and 60%. The humanities and social sciences tend to have higher rejection rates than the physical science journals. And actually, the rejection rates are lower for nonprofit journals compared to for-profit journals. And there's 75 articles submitted every day for publication in high impact factor journals. So there's a lot of journal rejection. You can overcome rejection by either appealing the rejection. Here you can check the journal's appeal policy on their webpage. Journal editors will investigate and may ask for an additional review or an editorial board member to reassess your manuscript. These are rarely successful, but it's worth a shot if you can justify your appeal. You can resubmit to the same journal, especially if you've received a soft rejection. They'll tell you to do additional experiments. And basically a soft rejection is, it gives the authors more time to revise their manuscript because we want to minimize the time from submission to final acceptance. But if we do ask for additional experiments, we'd rather have you do that on your own and start with a brand new submission number, and that actually resets the clock when you submit the new manuscript. So that helps keep the journal statistics very good. So that's why soft rejection is a pretty common outcome. And plus, the journal editors, they like your paper. So we would like to invite you to resubmit if you can do additional experiments. Or you may just submit to a new journal. If you do that, that's a hard rejection. And carefully choose a new journal and reformat your manuscript. And then use the reviewer comments you receive to improve the manuscript. So don't forget to address the reviewer comments, even if it's a brand new submission to a brand new journal, because you may have the same reviewers review your manuscript. So to avoid rejection altogether, it's important to choose the right journal. It's important to explain the novelty of your paper. You can explain what is new about your work. This is often can be done in a cover letter, and that will explain to the editor what is novel about your work. So make sure you can back up your claims that you make with convincing experimental evidence. You have up-to-date citations, check your spelling and grammar, make sure your figures are nice and clear with appropriate labels. Avoid research misconduct like the fake reviews, and make sure all your ethics are up to date. If you have drug trials and medical science, clearly identify your topic, hypotheses, and objectives. You want to organize your manuscript clearly and adhere to the guidelines of the target journal. And this will make you feel a little better. Some of the best papers in the history of science were rejected. They started out as rejected manuscripts. So in 1937, Nature rejected this seminal paper from Hans Krebs on the citric acid cycle. This is in every biology textbook in the world. Then he turned it around and published it a couple months later in Enzymologia. So that was a rejected paper. And here's a Nobel Prize winner. He wrote a paper on Fourier transformation and nuclear magnetic resonance spectroscopy. And he was rejected twice by the Journal of Chemical Physics before he turned around and published it in the Review of Scientific Instruments. So how can you go about writing the perfect thesis? There's a lot of good resources I like to share with you. Most of these are on the Editage's website. I'll also share a couple handouts with you, which I'll give to the India Science Fest hosts. So when you write a thesis, keep in mind it's much different than writing a manuscript article. The manuscript article is very short and concise, whereas your thesis is a complete work of your master's or your dissertation topic. And this is probably the last chance in your career where you'll basically have an unlimited amount of words and space for which to communicate your research ideas. So basically, journal articles are like distilled information from your thesis. So writing is very difficult. Here's a good cartoon on PhD comics, how it's supposed to work, but of course your emotions are getting involved while you're writing. So it's good to be organized and organize all your thoughts in a logical manner. And here's some key differences between a thesis and a journal article. The thesis, you can demonstrate how much you know, where a journal article focuses on small advancements. The audience for your thesis is probably your steering committee, whereas journal articles, it's more of a worldwide audience. A thesis can be very long, it could be 50 or maybe hundreds of pages long, whereas a journal article can range between 3,000 and 6,000 words. And basically, you can be extremely detailed in your thesis, whereas the journal articles, they want to have everything be short and concise and tell a really good story about the main findings from your experiment, whereas a thesis can be a lot more exhaustive and long. So I do have a couple handouts to share with you because we're running out of time on this first hour. So I'll share with you tips on how to make an outline of your thesis. Typically, when you do put together an outline, you'll have an introduction for your dissertation and a discussion, and usually your experiments, you want to sandwich your thesis with publishable papers, and typically the inside chapters of your master's or PhD thesis, these will be the the papers that you will publish. They'll be in a little bit of a longer format in your dissertation, and they'll be rewritten in a short and concise format, for when you publish your papers as journal articles. And each of those small chapters will have a miniature IMRAD, which is Introduction, Methods, Results, and Discussion for a certain experiment. So I will share these outlines with you as handouts because we are running out of time. This is a great way to give an overall outline of your master's thesis. So I'll share those with you at the end of this webinar. And then finally, there's some tips on writing your first draft. And this can be its own separate webinar that can take easily another hour. But I'll just provide these as handouts for you. And this gives you everything you need to know about writing your first draft of your thesis. The important thing is to try to get all your thoughts down on paper in the beginning, and then revise again. And there's a lot of books that I'd like to share with you about writing very effectively. And here are some titles, and everybody will get a copy of this PowerPoint presentation. So I'll make sure this is available to everyone. And here's some more writing guides for your scientific papers. So this concludes the first hour of the webinar, and I'd like to open this up for question and answers. I noticed there have been some questions posed, and I'd be very happy to answer these live.
Wonderful. Thank you so much, Dr. Vikram. That was very, very interesting. And I think lots to think about, especially for someone who's in the process of writing or is planning to write or intends to be writing. I mean, research is a field wherein you have to be writing for a long period of time. So I'm so sure that, this workshop has been of great use to all our listeners. Let's take the questions that we have over here. And thank you so much for putting all of that together. It was very, very useful. So the first question that we have over here is, so we know that you said that you'll be handing out a brochure of sorts for help for everybody. So for manuscript writing, are there any model manuscripts available on any website for getting a good idea?
So, well, I would just send people to the journals, and if you're thinking about submitting to a particular journal, I'd encourage you to read some of the papers that they publish there, and that'll give you an idea of the types of manuscripts that are submitted there, the overall structure, and you can also look at the different article types that they have. They have original submissions, which are longer articles, and then there's rapid communications, which are shorter articles, and they all have different word limits and also limits on the number of tables and figures. So I would just check to see and read each type of the manuscript type that the journal accepts. And all this information can be found on the journal's homepage. And they will give you tips to the authors. And they even have a calculator for how long your manuscript is. You can type in how many words you have, how many tables, how many figures you have, and it'll give you a calculator how long your manuscript is, and you can tailor it accordingly.
Oh,
so
wonderful.
I would just read relevant papers.
Oh, that's very insightful, definitely. Okay, so the next question that we have here is, how do we understand which preprint journals have more authenticity and better data?
So I think there's a centralized preprint server. It's RXIV. And this is the one they used in biology. And typically you'll state in your cover letter that you've submitted this to a preprint server. Some of my best friends in China are astronomers. They actually have an astronomy preprint server where they upload their papers. So these are very commonly used. A lot of the COVID-19 papers, the medical journals, I think, also use these RxIV preprint server. I have to warn you, if you do use these preprint servers, the plagiarism detectors will actually find it, and the reports will actually come back that is a very high text overlap. So you want to be careful. If you do get rejected because you have text overlap, let the journal editors know that you used a preprint server. So Nature magazine, Nature journal, actually they want to know the reason why you put your work on a preprint server. And it doesn't hurt your chances at those publishing venues.
That brings me to the next question that we have here. Now, plagiarism is a very, very discussed topic when it comes to research writing, and there are multiple plagiarism checks online. But how do we make sure which one's authentic, and that we don't end up uh, falling prey to a plagiarism accusation?
Yes, so journal editors, we tend to give the benefit of the doubt to the journal authors, or to the authors that submit their papers. So if there is text overlap, we just plagiarism is kind of too strong of a word, really. So I like to use the text overlap. There's just too much text overlap, because when you're writing a paper, you're using established methodology. So a lot of your methods may have text overlap. So to reduce that, maybe you should just cite the paper. We use the methods of, and then you use a citation. And most journals use the same, I authenticate service. So it is kind of like a centralized service that the journals will use. And basically you don't have to worry about like one journal using one and the second journal using another system, and maybe you're unfairly pointed out as being flagged for plagiarism. Basically you can ask for these reports and then just reduce the text overlap. Also, editage can also help reduce text overlap if that's one of the problems. I think some of these plagiarism detectors are too sensitive. So it is actually very hard to just try to paraphrase and just put in your own words what's already been written as text. So it is challenging.
I really like the way you said that plagiarism is too strong a word. It's more of text overlap. Really like that. Okay, let's do one last question before we move into the next session. So this question is about, are there instances wherein a paper which was rejected was accepted later on when the subject matter became important for its time? For example, research on COVID-19 done now versus 5 years ago.
Yes. So, yeah, unfortunately, some work may get rejected because it might be so groundbreaking that it's really hard to change a paradigm. Like, for example, the COVID-19 papers, probably 5 years ago, well, they don't exist, but maybe coronavirus papers wouldn't get a lot of attention. And all of a sudden, it's getting a huge amount of attention, and it may be a cue for you to resubmit that manuscript because all of a sudden its importance is really, really elevated high. Another occurrence that's happened frequently is some papers, after they're accepted, they might not get cited very much for the first like 5 or 10 years, and like some of the ecology papers, and then actually 50 years after they're published, they're getting tons of citations. So there's even some really good work that's published, and it takes a while. There's a lag before it gets the attention that it deserves. So hopefully the paper wasn't rejected in the first place. But yes, if it was rejected for being irrelevant, all of a sudden it might become extremely relevant. And I would encourage to submit that work again.
Yeah. So, I mean, I think timing has a huge role to play in instances like this. But anyway, Dr. Wickham, thank you so much for telling us all about how we could present the perfect thesis and get our papers submitted, accepted. It was really, really interesting. And I'm sure as we're going to be handing out the brochures to all our attendees, we will make sure that all of this is accessible to them. And now I would like to tell
Great.
everybody that we have a very interesting session that Dr. Wickham is going to conduct for us on international networking. Now, going to study abroad, pursuing research abroad is a very, very sought after topic, and it's something that a lot of us need uh, guidance about. So this is very, very relevant for everybody who's interested in going abroad and is interested in networking with researchers abroad. Dr. Wickham, again, thank you so much for putting this together for us. Over to you.
Right. So getting into the part 2 of this webinar series. This is on international networking for PhD and postdoc researchers. It's becoming more and more important to get international experience because science is global, as you can see with the COVID-19 pandemic. It's very important to be able to network and have colleagues and collaborators in different countries. And it's also important to get these opportunities, take advantage of these opportunities early in your career. And a lot of the first experiences you have in international networking is attending conferences. So I will be discussing how to give an effective presentation at a conference and how to network at conferences. And usually that's the first experience trying to network. And then later, after you present your research, these might turn into either PhD opportunities or international postdoctoral opportunities. And the theme here is just getting yourself out there. And when you're publishing in international journals, that's who your audience is. It's international scientific societies, it's international researchers, it's global engagement of your work. And if your research has worldwide appeal, you may have a greater opportunity, greater chances of doing a postdoc or a PhD abroad. So for those of you who did not attend the first session, my name is Jacob Wickham. I'm managing editor at Integrative Zoology for the past 7 years. And I'm currently an assistant professor at the Institute of Zoology, China's Academy of Sciences. And I'm also an adjunct professor at Rutgers University in the US. So I've been living and working in China for over 10 years now, since about 2010. What we gain from this short course, I'll explain why you should attend conferences, how to present at a conference, how to effectively network, and then what you're all very interested in is what kind of fellowships and funding opportunities exist for PhD and postdoc researchers. And I'll give you some tips, and I'll share some websites with you about finding and applying for international PhD and postdoc opportunities. And finally, what do international faculty look for in students, and also postdocs as well? So you can start by searching for opportunities. If you're thinking about doing a PhD abroad or a postdoc abroad, you can check out the Nature and Science careers. You can also check out country-specific or regionally specific opportunities. You can also check with your local college or university. A lot of these start at where you are right now, your local college or university. And that's actually where I started with my international experiences. I just opened up my email 2 days ago, and here's a list of careers and science careers. Nature also has a page dedicated to this. If you look at what's out there, there's a lot of professor positions. Um, but if you hunt and if you're carefully looking there, you'll see some postdoc opportunities and occasionally a PhD position, basically a PhD student position abroad. And they may be country specific, or here in the United States, it's like state specific. And this is a good place to start looking for opportunities, just to think about where you might want to go. Here's a list of my international experience. And if you don't have any experience right now, don't worry about it. I started out with zero international experience. I was an undergraduate at SUNY, it's a State University of New York, College of Fredonia, and I took a tropical field ecology course. And I paid for that myself, and that was my first international experience with research. I loved it so much, I actually returned that summer, and I took a tropical rainforest ecology course. And it wasn't through my university, it was actually a mix of students from the US, Canada, and Japan. And there's actually, there's a lot of organizations that actually fund field courses around the world. China has some, Indonesia has some, there's a lot of them in Asia. And I should put together like a list of courses and send to everybody. So my mother's a biologist, and she actually, we took a course together the summer between my junior and senior year. Then during my senior year in my undergraduate college, I did a 5-month-long internship at a tropical research station in Costa Rica. And this was a station that we visited when I took that initial field course. And again, that was a self-funded trip. I was able to collect some data on that trip, and I actually turned my that project into a master's project, and I applied and I got some funding from a foundation that's associated with SUNY Fredonia. So that was a wonderful opportunity. So it was experience that just a tropical rainforest ecology course field experiments where we visited a field station. I talked to the station managers and then their board of directors, who happened to be in Canada, and they accepted me as a master's student, and I was able to do a research project there. And this is all stuff I did on my own. There wasn't any existing programs. So sometimes you have to be very ambitious and just pursue your own opportunities. So later on in my career, this initial international experience turned into a wonderful experience for a wonderful opportunity for my PhD research. Because I had previous international research experience, when I got accepted into a PhD program, the project had a component of research in China. So my PhD supervisor was very quick to accept me because I had international experience. So it is important to get that international experience early. And then having done my PhD research in China, I was able to apply for a National Science Foundation fellowship. So this is from US NSF. So that was a good chunk of funding that supported my final year of my PhD project. And I finished my dissertation within a year of that NSF graduate fellowship. And I was able to land a postdoctoral fellowship with NSF. And to go from PhD to postdoc, you can see that the amount of money that is awarded was more than 10 times as much. So it really starts to open up opportunities, especially if you can get your own funding for projects. And then that started in 2010 to 2012. And I was actually able to continue my postdoctoral projects with Chinese funding. So I stayed in China, and when the NSF funding ran out, I was able to switch to Chinese funding. and basically extended all my projects, well beyond the length of my postdoc. And I was able to get like a visiting professorship and then Young International Scientist fellowships. And keep in mind, you may have to have more than one fellowship, when you apply for these opportunities. Like the CAS Young International Scientist Fellowship and this CAS President's International Science Fellowship, this only supports your living. So I can only use this for salary. I couldn't use it for research. So I actually had to apply for the National Natural Science Foundation of China Fellowship, and that was a research fellowship. So sometimes you have to have like a cocktail of fellowships, one to support your living, one to support your research. So it's also important to apply for more than one opportunity. And starting in 2015, I was applying for this NSF-NSFC project. And after getting rejected 3 times, this year we got funded for this National Science Foundation of the United States and National Science Foundation of China project. And you can see it's a very, very high levels of funding for this project. So things can start very like humble in the beginning. It could be a field course. You could be like sending an email to a professor to inquire about PhD opportunities. And you should follow up on all these things. It took a lot of legwork. There was no set programs, when I was an undergraduate. These are just things I pursued on my own. And I guess that's what professors will look for. They'll look to see if you're motivated, if you're resourceful, if you're persistent. And these can actually lead to bigger and better opportunities later. So effective networking. So to get yourself known and out in the field, it's good to attend some conferences. I know it's very difficult to attend conferences this year. Basically, there's the 2 biggest international congresses. One was the International Congress of Entomology. It was supposed to happen in 2020. That's postponed. And then the society where I work that runs the journal Integrative Zoology, we also have our International Congress of Zoology, and that was supposed to happen in South Africa in 2020. And that's postponed. So keep in mind, it might be difficult to attend conferences, but do look for online opportunities and or opportunities for webinars. That might be a way to meet colleagues. You may want to resort to more email communications, but assuming you can go to conferences, because this is all about presenting you and your work, and the personal interactions are key to establishing connections and networking. So here's a cartoon about, hey, professor, are you excited about the upcoming conference? Ugh, I hate conferences. The travel, the noise, the uncomfortable hotels, and the crowds. So it's good to get to conferences, whether they're national conferences or international conferences. Professors are, they might seem annoyed that they have to go to the conferences and talk to everybody, but it's actually the highlight of the year is to attend conferences. And especially after COVID-19, I think you can't wait to attend conferences again. So you want to learn about the latest research trends. If you are interested in a professor's work, make sure you read their papers. You can look them up on ResearchGate, on ORCID, and make sure you know their work. You want to learn and you want to share your research. So it's good to present your work. This is like the initial stages of networking. So you get to meet people, meet experts in your field. I was basically an unknown until halfway through my PhD project. And I didn't know anybody until after I gave my first presentation. It was actually a 10-minute student presentation. So a lot of these conferences are geared towards catering to students, and they'll have special symposia, special sections dedicated to students. And they tend to be shorter, maybe only 5 or 10-minute presentations. And they're usually set up as contests. There'll be a lot of professors that may be judging the presentations. So if you get an award at a conference, that's another way to get yourself known early on. So here's some 9 tips for a good oral presentation. Make sure you know your audience, whether you have a general audience or a specialized audience, and tailor your talk accordingly. Don't forget to follow strict time limits. A lot of the student symposia may only have 10 minutes, which means your presentation should be 8 minutes and have a maximum of 2 minutes for question and answers. Don't forget to practice in front of a friend or in front of your lab group. Check the room in advance. Make sure your presentation is uploaded. A lot of conferences have separate rooms. You can upload your presentation and check the presentation. Make sure your slides and your animations, or if you have a video, make sure that plays before you're in the room itself. You want to start confidently, maintain eye contact, use transitions, encourage questions and discussions, and ensure a natural closing to your talk. So remember, know your audience, understand the composition of your audience. It was good that the India Science Fest, we filled out a poll, so I know how many PhD students and postdocs and faculty are in the audience. You should also know who is in your audience. Your research is meant to be heard, not read. You don't want to just simply read off the slides. And typically audiences will have a limited attention span. So don't have too wordy slides. So what should you do? Use clear and simple language, be simple and straightforward, explain your technical terms, avoid using acronyms, provide a recap of the points whenever needed, and structure your talk with a background, findings, and conclusions. Strictly follow time limits. Typically, the moderator will clue you in. They'll give you like a 3-minute warning or a 1-minute warning. And things are on very strict schedules at conferences. So it's impossible that you're the only speaker scheduled for the day. So they'll also ensure strict time limits. So ensure that you prepare your slides based on the time allocated to you. Usually about 1 minute per slide is a good guidance. So you want to mentally go through your talk. You practice, rehearse if you can. Remember, this will take less time than when presenting your talk in front of an audience. So in the practice session for a 10-minute talk, if you're taking 6 minutes, you'll probably take closer to 8 minutes when you're actually in front of the audience. So practice, practice, practice. And practice your talk with a slideshow. And don't forget to record a video. That often helps. Once you're at the conference, if it's possible to visit the room you're trying to that you will be making your presentation in before the actual session. See how big the room is. Familiarize yourself with the computer, the laser pointer. So test the technology in the room. And be prepared to improvise in case something goes wrong. When you start confidently, like most first impressions. How you begin your presentation matters a great deal. Remember, the first 10 or 20 seconds of the talk, you can basically get people's attention. You may want to, if the moderator does not read the title, you can read the title yourself, or you can thank the moderator for introducing you and the talk. So the first 10 to 20 seconds, you want to start on the right foot and get the audience's confidence and attention. You want to engage the audience. So don't forget to smile, take a deep breath, and be calm. This will help you relax and dissolve any awkwardness between you and the audience. Be aware of your posture. Always stand straight and hold your head up. Make eye contact with the audience. Don't talk to the slides.
Dr. Vikram, just
Yes?
a quick question here. Does your
Mhm.
screen show international experience too? Because
Oh, yes, yes, yes. This is the networking. Let's see. Am I stuck on that one slide?
yeah, I think you are.
Okay.
So yeah,
Okay. I will see. Can you see the slides now?
perfect. Yeah,
Okay. I'm sorry about that.
no
So there's a
problem at all. Let's
technical
continue.
glitch there.
Yeah,
All right. So you want to maintain eye contact with the audience. Talk to the audience. Do not just read the lines on the slide. Take timely pauses to your advantage. That gives your audience the time to process and react to what you're saying. If you have figures, you may want to just take a step back and read the x-axis and read the y-axis. And that gives the audience time to understand what you have on your graph. Maintain a steady speech pace. Don't try to be too fast. And be mindful that the audience may have some non-native English speakers in the crowd. You want to use transitions. These are like filler words we use to move from one idea to another, like furthermore, in addition, consequently, meanwhile, finally. That helps to transition from one idea to the next. So in case you're using the same idea twice, begin your statement with a similar idea is, or another example is, so you can transition to new ideas. If you give a point-by-point explanation, you should first mention the total number of points. Like say that there are 2 reasons. The first reason is this, the second reason is that. And when you're introducing a new section or idea, you can say, let's move on to the next part of the presentation or move on to another idea. That's the use of transitions. And during the Q&A time, this is often the most crucial part of the talk because it gives you a chance to interact with the audience. And there may be some professors in the audience that you may want to network, you may want to join their lab, so it's good to engage with them. If you don't understand the question, you can ask the person to rephrase it. You can repeat the question to the audience. You can, when the professor asks you what the question is, you can repeat the question so the whole audience can hear it and then answer it. So if there's no questions are asked, you may want to have a friend in the audience and you can seed some questions. They can ask a question to get the Q&A series, the Q&A period going well. And ensure a natural closing. So if you feel like you've answered enough questions, and more frequently you just run out of time, you can ask the audience if there's any more questions and offer your contact information, and then tell the audience that you're open to receiving questions from them over email or WeChat or any social networking platform. And if there's no more questions, thank the audience for attending the session, and you can walk back to your seat. So networking. So after your conference presentation, when your presentation session ends, do not leave the room immediately. A lot of times there's mingling, and actually the most important interactions at conferences, they don't happen during your presentation. They happen in between the presentations, in between the sessions. So take the time to interact further with people who can still have questions. You can say, oh, I can answer this question after the talk or after the session. So you want to sit through all the talks that are in your symposium. So you give an opportunity for others to interact with you. So they may have questions that might be more preferred to talk one-on-one with you after your talk. Ensure that you have handouts and business cards ready for potentially interested individuals. And here are some common mistakes to avoid on your presentation. Don't have too many words on the screen. Make sure everything is legible. You don't want to have unstructured presentation, so make sure your points flow sensibly. Don't go over the allotted time. Look continuously at the microphone or at your reference notes. Don't do that. Don't skip your practice, and don't abruptly end. And don't panic. If you don't know the question, you can say, you can look into the question later and try to answer it the best you can. For networking, if you go to a conference, you may want to make a list of experts you would like to meet. Prepare an elevator speech. Like this is basically like a 2-minute synopsis of your research, and ensure that you have sufficient business cards. Be prepared to network. This will include participating in dinners, luncheons, and receptions. You can have mixers. It can be student mixers. It could be mixers organized by the university. It's good to attend these because it might give you a chance to interact with the professor that, during your talk, you may only have like 30 seconds to interact with them. But at these mixers, you'll have more time to interact with these individuals. So you can ask questions and make a good impression. Next day at the conference, after your talk, you can have an opportunity to talk with various experts in the field, and you can actually even go to one of their talks and try to ask some good questions during their presentations, and that'll get your attention. It'll get their attention. And that might turn into a PhD or postdoctoral opportunity. So you want to introduce yourself, discuss what project that you're working on, whether you have overlap in the expertise of the expert. And usually this is how these interactions happen at conferences. So it's good to get out there and get yourself known. So on coffee breaks or mixers, you can meet up with them. Typically, everyone has on a per diem, so their work is covering the lunches and dinners. You can offer maybe even to go out for a lunch or dinner to discuss the research. Probably a good cup of coffee or maybe at a poster session of the conference is a good place to meet up with somebody that you're wishing to work with. Here's some don'ts. Don't just hang out with your friends and colleagues. You want to branch out. You can network with people like maybe from Asia or the United States, wherever, or from Europe, wherever you're interested in working. Speakers of sessions you expect to be especially interesting or relevant. You can network with them. They're authors or participants of blogs or forums you usually follow. So those are good people to interact with during conferences. And of course, there's usually a few journal editors in the crowd. And they may actually invite you to submit a manuscript to their journal. So that's another good way to get your work published. Most of the big conferences, there are typically a number of journal editors networking at those conferences. And we're very interested in meeting, especially early career researchers. They may actually have some sessions where you may be able to meet with journal editors. And getting your work published is a really good strategy before you engage with professors, especially if you have a couple of papers that are published. The professor can read your work and find out more about what your research topics are. And don't forget to hand out business cards. You can print out some business cards, especially in Asia. This is important. And you can exchange business cards at conferences. So it's always good to have a stack of business cards in your back pocket. Okay, now to getting into international fellowship programs. Typically, these will be offered for PhD students, postdocs, and also early career professors. The United States has a Fulbright program. Europe, they have this really great organization called Euraccess, and there's actually Euraccess India, and they put all this information about opportunities for research, networking, PhD fellowships, postdoc fellowships, and all this information is condensed down onto one website, and there's one especially for India, and that can really open up some doors to Europe for career opportunities. And then there's the TWAS PhD and postdoc fellowships. They also have opportunities for early career professors. This is the United Nations sponsors this. This is the World Academy of Sciences. So India participates, Pakistan, Brazil, China, South Africa, and other developing nations at really world-class academies. And I think one of the prerequisites for this is you have to be from a developing country. And so this is open to individuals from India. And because I've been in China for the past 10 years, China has been investing just a huge amount of money and funding in international research initiatives. And the latest one is called the CAS President's International Research Initiative, or CAS PIFI. And this is opportunities from professorships, postdocs, and even some PhD opportunities. So to dive into these programs a little more depth, the United States Fulbright program has been going on for several decades. There's a lot of COVID concerns now, but this program is still going on. Here's the website for the Fulbright program. There's a lot of social science and there's a lot of hard science programs, and there's opportunities for students, also postdocs and early career professionals. Keep in mind, if you do a student-based Fulbright program, one of the requirements is you do have to return to your home country for 2 to 3 years following the completion of your Fulbright in the United States. So I've met several Fulbright scholars. I've been very impressed with the program and the quality of the students and early career professionals that are sent to the United States. So that's a good opportunity. The United States NSF, they also have some international opportunities for PhD students. There's like a dissertation improvement grant. Like if you're a PhD student in the United States, you can apply for that. But keep in mind, a lot of the NSF grants are only open to US citizens. So you may be excluded from some of those. So you may want to consider a Fulbright program instead. I mentioned Europe. So Europe has Euraccess, and they have one geared especially for India. So there's a website there you can follow and discusses careers and funding. So they provide grant and funding information for researchers wishing to travel to India from Europe and vice versa. Researchers wishing to visit Europe from India, researchers looking to locate funding opportunities, and researchers seeking to collaborate with partners in either Europe or India. They have monthly newsletters, and I have a website here for the newsletter. They're very well organized. All the information is online. Just note that during the COVID-19 pandemic, some of these travel opportunities might be delayed. But with the vaccine coming, I'd urge you to get in touch with potential or prospective professors and laboratories that you're interested in working with. It's great if you can bring your own funding. into a laboratory. That's how I was able to initiate most of my international research fellowships. You know, if a U.S. professor wants to bring in an international student, it's very expensive to provide research fellowships. So if you go through some national programs and get your own funding, all the professor has to do is host you and give you some laboratory space. So it looks really good if you can bring your own funding to the table. And then moving on to the TWAS fellowships. So there are PhD fellowships for developing countries, especially the least developed countries. There's a whole list of them, but the hosting countries are actually Brazil, China, India, Pakistan, and South Africa. And the placement research institutes are some of the highest rated institutes in the world. And they offer between 100 and 160 PhD fellowships per year. You can follow this website to find out more information about PhD opportunities. A lot of it comes with funding for your living. You'll have a stipend, and you'll have a chance to have your research also paid for by this fellowship. So these are excellent. There's a lot of great institutes in throughout the developing world, including China. TWAS fellowships also have postdoctoral fellowships and also professorships. So these fellowships can last anywhere from a minimum of 6 months to a maximum of 3 years. And they're hosted in Brazil, India, Malaysia, Pakistan, and Thailand. I guess China is off the list for postdocs. So I think that the TWAS, if you're interested in going to China for your PhD program, you can apply through a TWAS fellowship. But China is not on the list for postdocs. But there are other opportunities for postdocs in China. So moving on to the CAS President's International Fellowship Initiative. This used to be called the Young International Scientist Fellowship back when I secured this funding in the early 2010, 2014. And they actually offer fellowships for all the whole breadth of researchers, from PhD students all the way to distinguished scientists. So they used to call the distinguished scientist the Einstein Fellowship Program. And this is a lecture tour that lasts from 1 to 2 weeks. And then you'll host a CAS postdoc researcher at a CAS at the China's expense. So they'll actually come to your lab in your home country. And they'll offer you a stipend of about $8,000 per week. So that's the A level, the distinguished scientist. Here's for visiting scientist. I got one of these as a visiting professor in Chinese Academy of Sciences. So basically, if you're finishing up your postdoc, you may want to consider applying for the assistant professor level. That's the level that I got, and these are per month. So 20,000 yuan, about $3,000 per month. And it goes up as you increase your rank. So, and you can get started on this by having just a proposal, a cooperative research proposal with a CAS host researcher, and the intention to come to China. And finally, for postdocs, they have wonderful postdoc opportunities in CAS. There's age limits, so you have to hold a PhD that you've received in the last, usually within the last 5 years, be under the age of 40. And these are pretty generous fellowships. Keep in mind, these are only for living expenses. Typically, you'll have to apply for a postdoctoral research fellowship from NSF, National Science Foundation of China. Remember, I said sometimes you have to have a cocktail of fellowships. So I was able to secure the visiting scientist fellowship to cover my my living expenses, and then I applied for the National Natural Science Foundation of China, the Chinese NSF, to cover the research expenses. And a lot of the labs that host you are well funded, and sometimes they will be able to cover your research expenses. And you can cover your own living expenses with this fellowship. So again, this will cover research for over a 1 to 2 year period, and you can identify a good host researcher and develop a proposal for postdoctoral research. There's some other opportunities if you wanted to have a longer stay, more than just the length of a postdoc. There's employment opportunities for 2 to 3 years in CAS for special experts. And then for younger staff, they're trying to attract full-time researchers to work in CAS for up to 3 years. So in addition to your institute's compensation, because the salaries are quite low, if you have a local salary in China, this CAS Pi-Fi fellowship will give you 100,000 yuan bonus on top of your regular salary. So these are good opportunities for younger researchers looking for longer term employment, 2 to 3 years. Okay, and what are professors looking for in PhDs and postdocs? As you can see on the slide that stayed on forever on my screen about my path of being an international researcher, most of my initial opportunities were opportunities I pursued myself. They weren't part of any programs. They were through field courses offered by my university, and it's just going and contacting the managers of the field station and the board of directors of the field station that I wanted to live and do research abroad, and they were able to host me first as an undergraduate student, then as a master's student, and then that led to great postdoc, PhD and postdoc opportunities. So you want to show that you're highly motivated, highly independent, that you're capable of getting research grants on your own. For PhD programs, they typically would like to see you have a master's degree before you apply for a PhD program. It's important to have good presenting skills, so it's important to attend conferences and network with professors. I think more of the networking is done online now, so be prepared to attend Zoom meetings, webinars, and email professors. And as always, it's good to have a track record of funding and publications. And publications are very important, especially in China. They do want to see you to have a couple publications. So it's good to have at least one publication before you contact professors for international opportunities. And that wraps up the second hour of the session. I'd like to thank you for your attention. I know the 2 hours of sessions is long, and we still have an hour to go, but at this point, I'd like to take any questions that you may have. So thank you for your attention.
Yeah. Thanks a lot for the wonderful session, Dr. Vikram. I'll be taking over from Shruti. It's very interesting because as a young researcher, I think there are two bridges to cross. One is you do your research and you actually put it into paper, and subsequently there's another bridge to cross, which is actually to go out there and present your work and look out for collaborations and opportunities and so on. So it was really wonderful to listen to you cover the entire gamut of both of these. I have just looked for questions on social media and on the Zoom meeting. So there's one question on how relevant blogs are for younger researchers, and whether you would encourage young researchers to kind of maintain a blog and to update their work as and when they do something interesting.
Yeah. Yeah, blogs are now really becoming in vogue, and there's a lot of different media to use to get your research out there. And there's a lot of social media at conferences. They encourage you to use Twitter during the conference, and so a lot of these are becoming more commonplace. Um, a blog is actually a good way to introduce yourself virtually. And if you have like a website, you can put your CV on the website and and have a very informative home web page. And a blog can be a part of that. Keep in mind, blogs are not peer reviewed. So you can have a very strong opinion about something, but the real definitive um, uh, validation of your work is peer reviewed publications. So don't fall into the trap of spending too much time on your blog, and it's more important to publish your papers. But blogs are very useful to get your work out to the general public as well, because outreach is considered very important in the United States. It's actually part of a lot of National Science Foundation funded projects. It's good to visit schools. It could be even elementary schools, or like a photography club, to explain research. So I mean, these are different ways to uh, get your work out there. So blogs are relevant, but it should just be one facet of many multifaceted approach to getting your work out there.
One of our attendees is wondering whether it's necessary to kind of stick on doing the same kind of research as one would do in a PhD, and then subsequently continue the same for the postdoc, or do you see people changing track as well?
So all depends on your interest. It's easier to get a postdoc in a field that you did your PhD in, because that's where your most relevant expertise is. But in a postdoc, you may want to have a more multidisciplinary approach. So you may want to make your work even more broad to give it more worldwide appeal. But in general, it's a good strategy to stick to doing what you're doing best, because you've shown a track record of excellence in that area. And then you can use that expertise to branch out to other areas later on in your career. So keep doing what you're doing because you're good at it, but be open to branch out to new fields or cross-pollinate different fields, because a lot of the biggest funding grants and awards have multidisciplinary approaches. As I found out in my career, you can be very specialized, but it's good to keep yourself open to become more broad in your approach.
So as we are in the pandemic, one of our attendees, Zoom attendees, is wondering whether there are any virtual fellowships of sorts. Is that something which is happening nowadays, or?
To my knowledge, I don't know. Maybe there are virtual fellowships opening up. I mean, everything is moving virtual for the time being, like virtual conferences. And with the travel ban, it's really hampering scientific research, international scientific research, because nobody can travel now. So yeah, I don't know if there's any virtual fellowships going on, but if you look at the conferences and the meetings and webinars, I would not be surprised if you could work remotely for a postdoc fellowship. Yeah, so just keep an eye out for that. I would not be surprised if that opportunity opens up, but I do not know of any at the moment.
Well, thanks a lot. Thank you again, Dr. Vikram. It was a really nice talk, and as I mentioned earlier, it was really nice hearing about everything about getting your work across, and getting into a collaboration, getting to an opportunity wherein you can actually kind of go on and level up, and yeah, so it was a wonderful talk. Thank you so much.
All right, thank you. I'm going to stop sharing my screen and move on to the next presentation.
Sure.
All right, thank you, everyone.
Thank you, Dr. Vikram. Okay, so let's move on to the third session for the day, and keeping in sync with the topic of getting your research across and actually being an effective communicator. It's my pleasure and privilege to introduce Dr. Shivani Shah, who is currently a senior managing editor with Cactus Communications, and she is an established academic herself. She's done an undergrad at St. Xavier's College, Mumbai, in microbiology and biochemistry. She has a master's degree from Maharaja Sayajirao University in Baroda, and her doctoral degree from Loyola University, Illinois. And she also has completed 2 postdoctoral fellowships, and she's been in the space of science communication and research publication services. And we're really excited to hear your thoughts on how does one go about marketing research, or how exactly do you market your research. So thanks a lot for joining us, and over to you, Dr. Shah. We will have, as usual, a 45 to a 50-minute session followed up with the question and answer session at the end for about 10-15 minutes. And we also have a few polls. So Dr. Shah, you can let me know when to get these polls across. Over to you. Thank you.
Hi, thanks Abhijit for the wonderful introduction. And I guess this is the third session for the day. So you guys are probably already saturated with all the cool stuff you've heard about publication and networking and how to, make the most of what you're doing today. But I'm going to take it one notch up. I'm going to talk to you about what you can do more. Okay. So I'm hoping you guys can hear me, right? I've just started right in.
We can hear you.
Okay, great. All right, awesome. Okay, and you can see my screen too.
We can.
Okay, great. All right. So how do you market your research? And before I get to how do you market your research, I'm going to tell you why you need to market your research, right? I think my introduction is already done, so I don't really need to talk about who I am. As Abhijit already told you, I have a PhD in immunology. I have 2 postdoctoral fellowships. And during this time, during my PhD, during my postdoctoral fellow, all these years, almost 10 years in total, I enjoyed doing my science. Science was important to me, more so where I didn't really understand the importance of publishing. I didn't really understand the importance of communicating my science. For me, as a scientist, it was all about hardcore science. And I really learned about writing manuscripts after I joined Cactus. And this is really the phase where I learned not only how to write, but I actually enjoyed writing. And it made me understand why I need to publish, why I need to write well. And in the last, year and a half, I've been with Impact Science, where I've gone one step ahead to understand why it's not important just to publish, but why it's also important to promote and market your research, right? So let's just take a moment. For us, many of you all would have published maybe or are in the process of publishing. I'm going to ask that question to you guys in a little bit. But do you think this is enough, right? Maybe not, maybe it is. So during my time, like I said, I didn't like to write, but I knew that it was publish or perish. So if you didn't publish, you're not going to really survive in academia or in the science field. Now, what has happened in the past, few decades is that science is really growing. And there are more and more scientists out there, more and more people who are doing research, really good research, right? And it needs to come out. It needs to be well communicated. And the way you do it, obviously, one way is that you publish and people read your articles. But just publishing isn't enough, just because of the sheer volumes of articles that are getting published today. So what happens is that your needs or our needs in the science, community have increased. So it's not just about publishing. It's not just about publishing in high impact journals, but it's also about publishing frequently and in addition, communicating well, right? So you publish well, and then you also communicate about it. Okay, so let's have the first poll. Abhijit, can you put it out?
Yes, I will do that just now.
So as a researcher, where are you all? I want to know a little bit about all of you. Have you already published? You're in the process of publishing. So you're currently writing a manuscript, because publishing and the entire publication process is really long. So you could be somewhere in the midst of publishing, or are you just starting out? You're writing a manuscript right now, or you're at a stage where you're still doing your science and are hoping to be writing soon. So let's just take a look at where you guys are.
Could you see the poll result?
No, actually, that's what I'm trying to do. I'm not sure how. I can go back to the Zoom meeting to see. Oh, I get it. Okay. All right. So we have quite a few who've already published. Great. And we have, well, almost like 40% who will be writing soon. And then some are, in the process. So that's great. We have a complete mixed bag out here, and that's fine. So you're publishing in the modes of publishing, writing a manuscript, you understand the process, right? You have to publish. But why do you think you have to publish? Can anyone tell me? Feel free to use your chat box. If only I know how to figure out how to access my chat box right now. But please go ahead and start typing in why you think we need to publish. Abhijit, is there a way that I can access the chat box right now without stopping to share screens?
You can have a look on the Q&A tab.
I can't see that anymore. So as soon as I started sharing screens, everything is gone, and I have this small minute view in the corner.
Okay, do you see 3 dots?
Yes.
Somewhere?
Pin video, hide self view, stop video, mute my audio, rename.
Okay, I can do one thing. So as and when people put down things on the chat, I can read it out to you.
Okay, really sorry. Maybe I might have to stop sharing screens to be able to view. Guys, anyone, why do we publish? I'm sure you've heard a little bit in your past, in the morning session as well. Why do we need to publish? No one? Okay, I guess.
Okay, so Said says usually publishing helps to make our work visible to the research community.
Okay, all right. That's good. Anything else? Why are you publishing? Why are you writing that manuscript? How is it? Why is publishing important? Why does anyone write a manuscript? Other than, yes, what Said said is absolutely right. All right. So why we write? Okay, we write to make your research accessible to others. And I think very importantly for all of us, we write to graduate. Okay, we write it for our career progression. Because without writing about your science, without writing about your research, you're not going to get funded. You're not going to move ahead in your career ladders, right? So it's important to publish. It's important to do it at the right phases so that you can progress ahead in your careers. Okay, so why do we, now you know why we publish, right? Why do we need to promote it? Okay, you published, you got your paper, you can put in your CVs, but why do you need to promote your research? Well, to become visible, because as more and more people read your article or read your research, they're going to know you. So that's indirectly going to affect your future opportunities, both career-wise as well as funding-wise, right? And if you're a true scientist and you're really passionate about what you're doing, then yes, to make your research accessible to more people and obviously in the end to make a difference, right? Because you're doing really cool stuff, your findings are really cool, but if no one's going to read about it, no one's going to know about it, right? Okay, let's get some perspective. So today, there is a global scientific population, right? And it's growing day by day. There's over 8 million researchers out there. And as the number of researchers are increasing, we are having more and more articles published. There's over 3 million articles. This data is as of 2018. So you can imagine that this number has exponentially grown since, especially with the pandemic last year. So, or well, maybe we are still in it. So science is growing and it's growing by leaps and bounds. So you have so many more published articles, and there's so many journals, over 33,000 journals that are out there. So when you publish, your work essentially is getting embedded in this, huge sea of information. And let's face it, academic articles, research articles are written in an academic style that's formal and informative, but also in a manner that's not always easy to understand. Okay, how many of us can read an article, read the abstract, and really just get everything that's part of the study? I know it's sometimes really hard, and I have to go in and dig in, the results or the methods or even the discussion to really understand what the paper is about or how the research was carried out. But this is just the way it is, right? This is how academic research is written, but it doesn't have to be. We can make it more fun and more interesting, more popular, so that it is more accessible, right? So more people can read about it, more people can understand it. Now, go with this, all right? Do you remember this? Does anyone know what this formula is? Or I don't, okay? I don't know what this is, but I do know what this is. How many of you all know this, right? It's Newton's story, and it's about how he learned about gravitation and how he formulated that formula, right? So there is a way of storytelling where you can convey things much more simpler in a format that more people can not only understand, but perhaps even remember, all right? Let's face it, when scientists talk, they think they talk smart and they think it makes sense because it makes sense to them. But in reality, very few people outside their community really understand what, what they're talking about, what their research is about. So when they talk, it's confusing, or it can be confusing, depending obviously on how they're conveying their research or how they're talking about it. If a scientist makes a discovery, but no one hears about it, can the discovery make a difference? Well, I don't really know, because depending on who hears about it and when, yes or no, right? So it's again important here. The point I want to make here is that it's important to get your word out in a manner that people are reading about it. Also, get it out in a way that people understand. So it's not just enough communicating, but it's important that you communicate in a way that people can understand. All right, let's take this scenario for instance. So why is publishing not enough? All right, let's take this scenario. So you're thinking of publishing in an open access journal. So already an open access journal means more people are going to read your article because it's freely available, right? It's not behind these paywalls that people can't access beyond the abstract. So it's an open access journal, good, reasonable impact factor, and yeah, important is peer review, right? So you're happy, your work is getting published, open access, reasonable impact. Who's reading this paper, right? People within the community, and who is this work going to appeal to? Just that niche audience who are reading the paper, typically people who are in that field. Now, think about an option B journal. An option B journal, again, is open access, similar impact. And in addition, it also offers different modes of talking about your research. So you can have videos, you can have infographics, which can then be shared on social media. So what happens to your research now in this case? Well, more people are going to read it, right? Because it's available across different platforms. And who is it going to appeal to? It's going to appeal to a wider audience, not just the scientists in that niche field, but also scientists across, maybe policymakers, maybe funding people, maybe industry. Like it could go to so many different avenues. So when you're making the decision between option A and option B, at least if I was in your shoes, I would be picking option B, because I know that this journal is offering me an opportunity to distribute my work, or disseminate my work rather, in a more, in a wider manner. All right. So what will promoting your work help you with? Okay. So it's going to help you stand out, because more people are reading it, more people are talking about your work, and it's just going to make you more visible. So not only going to reach out to more people, you're going to increase the impact of your work, and it's going to help you with opportunities and, either career-wise or to collaborate with other researchers who may have come across your work. And today, collaboration is actually really big, because I might know molecular biology, but my study involves the use of chemistry, because I want to figure out how drug A is doing, particular thing in the cell. And I might need to understand how, mass spectrometry works, or something really fancy. So there's so much integration between fields where I may not have all that expertise. Okay, so I will need to collaborate to really get down to the bottom of whatever I'm trying to find out. Okay, so collaboration is more and more becoming important, and getting your research out there is definitely going to help you get there. All right. Abhijit, can we have poll 2, please? So I'll just ask out another question at this point, right? How many of you have already promoted research, think that promoting your research will increase your visibility, or are really not sure whether promoting can help? Like how? Let's see what you guys have to say. Guys, please do it so that I can understand how you guys are all thinking about what we're talking about. All right, so here we are. Most of you all are thinking that you're, promoting research will increase visibility. So that's great. And maybe the session then will be very helpful for all of us. Okay, moving on. So promoting research, right? Who is this going to impact? Obviously you, we've talked about that. It's going to increase your visibility. But it also helps publishers. And in fact, a lot of my clients are publishers who want to promote their articles. And this is done primarily not just for the author's sake, but also so that more and more readers come to them. So their subscription increases, and it's a win-win situation in all ways. Right? This research promotion also impacts funders and policymakers, because in the end, higher the impact of your work, higher the chances of you getting funded, and possibly even, affecting future policies that are yet to come. Okay, so it's a win-win on all fronts. How research promotion will help. How do you do it? Okay. You can use different formats for communicating your research. And one of the first ones is social media. I think most of you all will be on social media, some form or the other. And all of you all are probably using it more for your personal needs, but there's a lot of science out there. Okay, there's Twitter, there's Insta, there's Facebook, and LinkedIn obviously is different, where it's more professional. But no matter which social media platform you go with, all of them have a high science and a high research presence. Okay? So you can follow people and you can post your research out there in snippets and tidbit forms that most people can understand. So you need to simplify it, but you can disseminate it and talk about it so more people understand what you are doing. Right. Once you identify the platform, what are you going to do, right? So say, okay, I want to tweet about my work. What are you going to do with it? First of all, you have to figure out what you want to talk about, right? What your key message is. You're going to talk about what your key findings are, or if it's a new methodology, you're going to talk about the key take home that you want other people to understand, right? You're going to include a link to your published article. You can use hashtags. These are a great way to, lead other people to your particular, post, and use smart hashtags, okay, so that these are all important in people coming to your post. Right? Mention people whose attention you want. So put them in there so that they come see your post. You can talk about your research journeys in addition, and very good way is to include visuals, because visuals is really what attracts people to your post and will increase the chances of your post being read or shared or retweeted. Okay, how will social media help you? It's going to help you connect with other like-minded researchers. It's going to help you build contacts, promote your research. Obviously, that's what we're talking about. It's also going to, hopefully help you with future funding, obviously share your views, and in addition to all of this, where you're promoting your own work, it's going to help you stay connected and updated where you don't have to sit and sieve through all the information that's out there. So you can follow. I know faculty professors who are on Twitter, and they follow certain journals or certain authors or certain big labs, right, who are in the field, and this way they don't need to always be on top of all the literature that is being published, and the new things that are coming out in your field. So it's a two-way street. You not only just promote your work, but you can also keep abreast of the happenings in your field. Blogs. I know somebody asked this question during the previous talk at the end, but blogs are important, and yes, I would highly recommend it. Yes, they are not peer reviewed, but at the same time, you can use this as a platform to talk about your research, to talk about your study, to talk about your interests, and to it's a space where you can express your opinions without peer review. And very importantly, I think blogs help with writing. So if you are a good blog writer, you're improving your writing skills. And believe me, writing skills are going to go a long way no matter which path you choose in your careers. It's a win-win when it comes to being able to write well and communicate well, whether it is science or anything else. All right. Press releases are another way. It's another outlet, basically, where you can put out a short article and have it, reach news outlets. And this way you're reaching out to absolutely anybody and everybody who's interested. Okay. Or maybe even not interested. Okay. All right. So how will blogs and press releases help? They will obviously increase your global visibility, right? They're going to again attract potential funders and collaborators, and thereby it's a great network building tool. And lastly, I want to say that they help with paper altmetrics. Okay? Now, I don't know how many of you all know what altmetrics is. So here is what is an altmetric score. Basically, it's a means to analyze the outreach of a certain paper. Okay? So earlier it used to be all about how many views you might have, or if pre time when everything was not online, there used to be journal subscriptions, and people knew the journals would know, the publishers would know what their readership is. But today, because not everything is restricted to subscription and so much is out there online, it's becoming more and more important now to monitor the impact of a paper, not just by people who are reading the paper on journal website, but also by all the social media platforms that you're posting on or you're blogging about. All these things also contribute in an impact, right, of a paper. It's not just about citations and downloads, but it's a lot more. So what this altmetric scores do is that they help analyze what the true impact of the paper is across all these different platforms, be it social media, be it news outlets or blogs, etc. All right. Why is altmetric important? Well, a lot of the publishers and journals are now using altmetric-based analysis. So it becomes like a feather in your cap when you have a high altmetric score on your paper, and you can say, hey, I may not have so many citations, but I know so many people are reading it and sharing my work. So it's definitely cool. All right. So who's using it? Like big publishers like Nature, Elsevier, Wiley, these are all using altmetric scores, and higher the score, better the outreach of your paper. What gives you that high altmetric score, right? What in your paper, or what in your what about your paper is going to help? Obviously, the science is important. You need to have good science. But in addition to that, you also need good visuals. These are key to attracting people to your work. So you can have it in the form of a graphical abstract or a video summary. And these are all non-traditional methods of research communication, right? It's not the actual paper. It's not even a figure in the paper, but these are all additional things that you can put about for your paper that will lead to an increased impact, because more people are going to read it and more people are going to understand it. It's not just about reading, it's all about how easily you can understand the paper, and if you like it, you might even share it and pass it on to someone else who you think might be interested. Okay, so these non-traditional methods simply aid in disseminating your work and then thereby contributing to the altmetrics course. In addition to this, obviously, if you write about it, so you can blog or press release, those are definitely going to contribute to the altmetrics course as well. Okay, so what does this mean? Why should you, whatever I've talked about so far, why is this relevant? Well, today it's more and more important that you communicate effectively, okay? And this is what I'm talking about. So you have publishers, researchers, and organizations at the center of all the dissemination. And it can go so many different ways. There's so many different ways you can talk about your research. You can obviously go through your social networking sites. You can have news portals. So you have things like Rec Alert and Fight.org, where they write about new and upcoming cutting edge stuff. There is several publishers have their own media outlets, so it goes out there. And obviously you have mass media, so you have journalism where your research can go all the way out to magazines, to newspapers, and news sites as well. Okay. Now you say, okay, you've talked about why we need research promotion, why we need to communicate effectively, where it can go, but how do you do it? Like, what do you put up on your social media sites, and how can you really talk about your work better? So there's several different formats, and the first thing I want to tell you guys is that no matter which format you go by, the bottom line is that you have to break down your work, because no matter how easy it is for you to understand, it is, or it may not be so easy for someone else to understand. Okay, so break down your work, make it less complex, make it easy for other people to understand. And you can do this by, but you can achieve this in different formats. So you can use, you can bring it down to a graphical abstract or a poster. Now these two, all of you all are probably already aware of, because a graphical abstract may be now mandatory for several journals for publication, right? You need it along with your submissions. Posters are used at conferences, and they are important ways of conveying your research, but these are more academic. Both of these are in a way more academic oriented, and they may be more technical. But then there are these other formats that you can make really simple, and these are really not necessarily academic. So you have infographics, where it's a visual representation to show all your data, but it's also a complete overview of your study, right? And then there are video summaries, which take it one step forward. So it's not just graphics, but it's like a movie trailer. So say you can hook your audience in by this really cool, 1 or 2 minute video that talks about your science, and it's animated, and it may or may not have a narration, but if it has a narration, then obviously it's easier for people to understand what you're sharing in the video. And this is all going to eventually lead to increased viewers, increased readership of your published article as well. In addition to these formats, these are all visual formats, the way I think about it. Graphical abstract, poster, infographic, video summaries, they're all visual means of conveying your story. In addition to that, we have podcasts, which are audio versions, and this is normally used or, normally relevant for people who don't have time to sit down and see something, and they're on the go and they can hear about the latest article that's published, or hear about what experts are saying about within their fields or even outside their fields. And the last way is I've clubbed these together, these summaries and research news stories. While these are research, these are both summaries of the study. They are very different. Okay, the tones, the language, the style of writing is very different. But these are both writing. They're articles, right? So they're short little summaries of your work. So there's no visual component in any of these. All right, so a little more in detail on all of these. First is the graphical abstract, and I think perhaps most of you already know about this, but graphical abstracts basically explain the key takeaways of your study, and they're in a visual format. So you have the methods, and you have the results, and the key take home at the end. And there's very minimal text involved. So the focus, the idea is to visually kind of grab the attention of the reader. And these, like I said, are typically linked with your articles, and now many of them, it's become mandatory where journals are saying, you have to submit one along with your papers. Another really academic way is a poster, and posters, or even for oral presentations at conferences, you put up, and you can see here the stark difference between an abstract and a poster. So while both of them really have condensed information, there's just a lot more text in the poster. Right? So you have all these details on introduction, methods, and we're actually putting in the figures straight up from the paper. So this is a paper, a figure in the paper that has been put into the poster. And today, as more and more conferences are becoming virtual, the size of the poster is changing, and the content that's going in is also changing. So it's likely that today's poster is a lot more condensed, and really it needs to be more impactful than the posters that I used to make back in my day. The posters were huge, they're displayed on a board, and I can put in a lot more information and talk about all my research. But the bottom line for both posters and oral presentations is that it allows for interaction and collaboration. Okay. So remember that when you're doing a poster, when you're creating a poster, or when you're looking forward to an oral presentation, think about not just conveying your story, but also about how you can network and collaborate alongside. Okay. Infographics. So an infographic is slightly different from a graphical abstract. Because graphical abstract, you're focusing very much on the key aspects of the methods and results and the conclusion. But in an infographic, it's typically an entire overview. Okay, so it's talking about the background, the methods, results, everything is there, but in a bite-sized format, in a visual format that's easy to read and digest. Now, I've put up some examples here. Right? So an infographic can be, the layout of infographic can be different. Okay? And it depends on how you want to talk about your work. So this is the same content. The content isn't changing, but the design is changing. The way you're reading this infographic versus this infographic is different. Right? The first one is more explorative. So you're looking here or here or here, and you can go wherever you want, wherever. So say I like cheese. So I'll maybe start reading from here. I'm a vegetarian, so I might never get down to the meat. Whereas here, it's very structured. So the reader is drawn to the subtitles starting one here to here to here to here to here to here. So there's like a set layout. Okay. So these are all choices that you would need to make when you're creating your infographic, or think about when one is creating infographic, is to think about how you want your information laid out in that little piece of in a little piece of art. All right. So like I said, there are different types of infographics. And in addition to what I just told you, you can also have different sizes and different orientations. So you could have a landscape version where it's easy to disseminate on certain social media platforms, say like Facebook or something that maybe, or LinkedIn, where it's easier to see it in a landscape orientation. Things that are routinely displayed on a laptop or a computer monitor, those, if they are landscape, then it's easier to read. But for other things, such as Insta, something that's typically viewed on the phone, it's better to have it in portrait mode or in square mode, where people can scroll down, or just have that bite-sized view in one go. Infographics can also be really made simple, so everybody and anybody can understand, or they can be made more technical. So this will depend on your readership. So say I am a neurologist and I want my research to be, read primarily by other neurologists, then I would make it a little more technical. I don't need to go down and explain what a neuron is. But say if I want my infographic to be accessible to my friends or my neighbors, then they might not know what a neuron is, and then I need to explain what neuron is. Right? So just an easy way to think about the layout in a landscape mode here is that you would have the title on top, you would have background, you would have methodology, results, and key message. And it doesn't have to be this layout. This is just like a sample where you can see that often these are distinct sections, right? And it's easy then to follow what is happening where and how to read in your study. These are just some examples that we've made. This one, as you can see, is on regenerative therapies. We've done chemistry, we've done neurology, and these are literally just samples of a wide array of infographics that we built. But a common thing that you can see in all of them is that they are vibrant, they're colorful, they're informative, they break down your study into something that's easy to read, and perhaps within a span of 5 to 7 minutes, you can assimilate everything there is, or not everything, but the key aspects of the paper, and maybe even draw you to going and finding that paper and reading about it. Okay. How are infographics effective? Well, we already talked about how it's an overview, and it talks about the entire paper. It's easy to understand, easy to digest. It has high recall value simply because of that. Graphics make it, again, more interesting, because without graphics, only text can be harder to take in, depending on the length of it, obviously. And the formats make it easy to share on social media or wherever you want to share it. So, and yeah, it contains a key takeaway message. So basically, long story short, you brought your story out, and whoever's reading your infographic is likely to understand what has been done and why it's important, and how how it's going to impact the future as well. Okay. Social media engagement. So this is something that we did for the Journal of Bone and Joint Surgery. And here you can see, this infographic is what we created for JBJS, and they posted it up on Twitter. And in no time, there have been numerous retweets, and people are even commenting on this is, how this is a great way to summarize the paper. Okay. This is another sample where we've created infographics for Chemical Science, which is a journal published by the Royal Society of Chemistry. And this one actually got featured in the Sunday Times. So it's not just in the social media platforms, but it's got picked up by news outlets as well. Okay, so the dissemination is much wider than what you can imagine. And yeah, there are a lot of shares. So there, obviously people who are sharing this information and reading about it, and possibly going back to the paper on the journal website and reading the article as well. Video summaries. Yeah, they're just basically one step further, right, from an infographic. Now, where whatever we're talking about, infographic is becoming animated and built into a narrative. So typical, a good length of, for a video is about 2 to 3 minutes. It could be shorter, which is fine because the idea is to engage the audience. And there's this use of graphics and animation, motion, and audio if it's narrated. And that really helps in readers getting more and more engaged with your work. And yeah, again, there's minimal text, and that helps because people aren't getting bogged down by words and they're really just taking in this cool story about your work. All right, so again, how are video summaries effective? It's very similar to infographics. So there's a snapshot. It's almost, it's an overview of your study. It has a narrative tone. So that's an extra bonus point from an infographic. Again, easy and quick to digest. Format is easy to share on social media platforms. And obviously it has a high recall value because you're really engaging the audience in this process. This is a sample of what we did for JBJS. Again, they put it up on YouTube. It's a video. And as you can see, within just a couple of weeks, there have been so many people viewing it. So yeah, yay, because this has really reached a much, much wider audience than would have been expected out of just an academic paper. And you ask me, what is the impact? Why would is this really working? Yes, more and more videos and infographics are viewed and, shared. And there's just far many more clicks and interactions that we can monitor. Podcasts are another way. We have, like I mentioned earlier, this is an audio format, and it's like a radio program where you have a host and you have, guest speakers, and it's very conversational. So it's easy to follow and understand. And podcasts are often free. So they're available on either journal platform or other specific podcast platforms where people can access and hear about the science on the go. Okay, so these are some samples. Several journals or publishers, both, they have podcast options that researchers can read about and primarily first hear about and then go back and read the article as well. All right, scientific press releases. These are written in a newsy way to attract a wider audience. They're typically picked up by news portals, and the bottom line for scientific press releases are that the scientific jargon is kept at a minimum so that, again, more people can understand what you're reading about. Okay, these are effective because of the worldwide dissemination and the potential collaboration for funding, the publicity for both the researcher as well as the journal or publisher. Could also be important for the institution wherein they are promoting their researchers' work, right? And these may or may not be accompanied by graphics, but when they are accompanied by graphics, this is how you would see it. So there's a mini infographic along with the article, and then that definitely attracts the attention of the reader and makes it easier to understand and recall as well. So far, traditionally, okay, we write the article, it gets published. There are all these authors who are reading it. These are the core audience. But this is it, this is how traditional publication works. It's a one-way communication. There's only one format of content writing, and there is limited engagement, right? But today, with all these additional content formats that I've introduced you guys to, what these do, and along with, putting it out, disseminating out through social media platforms, basically not just these three authors who are reading the primary paper, but there's, it's in a feedback loop where more and more people can reach to your paper because there's more shares, more likes, more converts. And then eventually this reaches peers and public and policymakers. So it's reaching a wider audience. And again, all of this goes back into the same loop. And there's more and more people who hear and read about your work. So I think it's a multi-way communication. It's probably not even just two-way. It's definitely multiple formats, and the engagement is much wider. All right. So I hope you've learned a few tips today on how you can sound like you think you sound, right? So you create all these easy ways to talk about your science and really put it out there. Okay. I have one last poll, guys. Abhijit, if you can help me with this. So after this talk, do you think science communication is important? Yes, no, maybe. Yeah, anyone taking the poll? Yes, everyone, 100% yes, that's awesome. Well, I'm glad to hear that. And I really hope that these pointers and things that I've discussed will help you down your roads. And with that, I will take any questions.
Thanks a lot for the wonderful talk, Dr. Shah. And it's very interesting because, like you mentioned, altmetrics, because otherwise, students like me, we're very used to kind of hearing about H-index, citations, right? So how many citations does this paper have? What is the impact factor, and so on. So it's really interesting how I think there's been a paradigm shift in the way impact is measured, and also how quantitatively it can be done right now, because it's very easy to get these numbers, and it's very easy to see how the impact translates and has this sort of a ripple effect. So it was absolutely wonderful listening to you talk about all of that, and I'm sure people are going to take back all of this and start working on ways to express their research better and more effectively using the ways that you mentioned. So we have some questions.
Yes.
We can go right ahead. Okay, so this is an interesting one. So as an editor, how receptive, or what is the response of researchers been like when you kind of mention to them that social media is actually something which is important for them, when it comes to communicating their work and so on?
So I'll tell you out of personal experience, 90% of my clients today are publishers. Okay, so publishers, journals, editors are people I am, interacting with day in and day out, and they are the ones coming to us with saying, "Okay, help us. Give me a solution. How do I increase my leadership? How do I get more people to come and subscribe to my journal? Help us come up with ideas and solutions to get this to happen." So we have a lot of publishers, a lot of journals, and yeah, really, they understand more than us probably. They are already there. And they are on all these social media handles. So actually, if you go to, say, Twitter, you can follow JPJS, you can follow RSA, you can follow all these publishers, you can follow all these journals and keep abreast of whatever they are publishing or whatever their authors are writing about. So yeah, it's definitely there, and they understand it just as well as we do.
So there's a question on how the use of graphics, and I'm assuming infographics and so on, actually is slightly subjective and depends on the nature of research. So the attendee asks, for example, in a field like theoretical physics, for example, and mathematics, how can researchers in these fields kind of condense their work and make it more accessible? You know,
So we actually have several authors who have come to us with things like quantum physics or with things like hardcore statistics. And what I would say is that as the researcher, right? You understand most about it. Okay. When you do research, why are you doing research? Why are you studying that particular topic? There's some reason why you think this topic is important, right? That's what you're going to bring out. And the idea of using graphics and visualizing is to be able to communicate that story. So it's not necessary to have that formula up there, but it's necessary to talk about why that formula is important and how that formula is making an impact in your field. So it's easier said than done, I know, because I always find physics very, very daunting, or hardcore chemistry. I mean, I have a master's in biochem, but still chemistry can be daunting for me. So it's, if you can talk about why, that's going to be your goal. It's not the nitty-gritties that are going to go into an infographic. It's not the nitty-gritties that other people are going to understand, but it's the why that they will understand. Okay. So if I talk to you about, okay, I'm doing this, say I'm doing material science. Okay, I'm trying to find this new nano product that can help with, say, drug delivery system. But I am studying on how to build that nano product. Okay, so I'm using nanotechnology. I'm using all these fancy equipment, and I'm creating this material. So if you're writing an academic paper, you're going to write about how you made the material, and all the things that all the math and all the stuff that went into creating that material, but or the chemistry, whatever is going into that. But when I'm creating this infographic, I'm going to talk about how this product is going to be valuable in the market. Okay. So it's the big picture. I hope that answers your question.
Okay, this is actually a question from a Facebook user. And the person asks, how important is, do you think pedagogy needs to be changed? When it comes to a subject like science communication, do you think there should be a shift in the way people learn how to do and communicate science? Or
I'm not sure I really understand. So you're asking, should there be a shift in how people do science so that they can communicate better, or?
No, I think the question is about the existing curriculum when it comes to presenting science, right? So
Curriculum or research? What are we talking about?
So the question specifically asks about pedagogy and curriculum. So I'm assuming it's at the university level.
Okay. There are ways in which you can convey or learn or teach a particular topic, right? So traditional textbooks, traditional ways that maybe I learned or you guys are still learning definitely there's so much improvement you can do there. I don't know if I'm really getting to your question. I'm still not sure if I've really understood what the question is about. But yeah, it's all about communication. So be it at the curriculum level, be it at the research level, be it at the any field, anything. If you can communicate well, you are going to reach to more people. And also, even during your classroom sessions, there are so many ways you can talk about DNA, for instance. Right? You can bring in these videos, you can bring in visuals, or you can go back to the textbook and just tell them, okay, DNA is a double helix, blah blah. So definitely visuals will help, definitely videos help, because I think I see that now even with my kids' school and all the teachers are using videos to explain to them a certain concept. And it's the concept again, the bigger picture, that's important, even in while learning at your university level.
So this has been a recurrent question. So folks are asking, what are the resources or softwares that you would recommend for making these infographics? Whether there are any online tools or templates that can be,
So if you really want to make a good one, okay, you can use PowerPoint. Simple, basic, you can use PowerPoint to make it. But the quality and resolution isn't going to be that great. What we use is Illustrator. Okay, that's by far, and according to me, the best software that's out there. But a lot of scientists also use something called Affinity. So it's slightly different than Illustrator. There is Canva. Yeah, I think these are the good ones that can be used. It's not so easy. So I mean, I'm not a designer. So if you ask me, I can't really use Illustrator. I can use PowerPoint, but I don't know how to use Illustrator. So these are tools that you would have to study and learn before you can really make something beautiful.
So I have a question. So how does a young researcher, someone like me, if I want to learn this in a structured manner, would you recommend courses, or would you recommend kind of self-teaching myself bits and bobs here and there?
Okay, define this. What are we talking about? Because what I've shared today are very different skill sets. Okay. So if you're writing, say, you're writing a lay summary, that is a writing skill. If you're creating an infographic, that's a breakdown plus visualizing skill. If you're writing a video script, again, that's a writing plus visualizing skill. So all of these require different skills. Writing can primarily be done by writing. Okay, I mean, there's no other way. You have to write. There are some courses you can. I think Udemy has some courses. Coursera has some courses. So if you really want to go the course way, you can do writing courses. But it's all about experience. You've just got to keep reading and writing and blogging, if you may, because that will help. And the more you read and the more you do, the more you learn. And you know, okay, this works, this doesn't work. And I have more people who understand this versus this. So it's all about practice and experience. But I would recommend it because this is really the future. I think all of us need to communicate. I think in India, everywhere actually, in India maybe more so, where these are now new things. Earlier, it was very, very academic, very, 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 okay, you do science, you publish, you're done. But communication is becoming very big now. Institutions are making this mandatory for progression. So it's not just publication, it's more than that. It's more than that. So, yeah.
I think that was extremely insightful, and thanks a lot for sharing all the actually, even like you'd mentioned, different skill sets, right? So it's not very easy to see what are the sort of branches that one needs to be good at to kind of have this
But you can use what you are good at. So say if you are really good at writing, you don't need to visualize it. You don't need to create that infographic. You can go with just the writing. So that's perfectly fine. And if you really need help, I mean, there are people who can help you. Like we're there. There are other freelancers. There are other people who are designers and can take your content and create it for you. So make use of people who are doing these things. And in fact, there are a lot of researchers out there who have these visualizing skills, and they're really good at Illustrator and things like that as well. So I think, yeah, it's all about, again, it's about knowing how to do more than one thing, using all your resources at the end of it.
Yeah, I mean, it's great to know. So I'm sure everyone will kind of now understand what to improve upon, and how do you be a better communicator when it comes to communicating your research and so on. So thanks a lot, Dr. Shah. Thanks a lot for coming on board the India Science Festival. And we look forward to interacting more with Cactus, with Upskill. And I have also shared all the links on the chat. So all the attendees can actually go and look at the Cactus website, and they're also on Twitter, Instagram. So I've also mentioned those links. And I think you can also connect with Dr. Shah in case you have any questions.
Absolutely.
Thank you so much. Thank you. Thanks a lot again for
Thank you.
about your work. It's a pleasure having you.
Thanks.
Okay, I thank all the attendees for joining us for the morning session on day 12 of the India Science Fest. We really look forward to seeing all of you again today in the evening. We have 3 excellent talks lined up starting at 5:30. So do stay tuned. You can have a look. You can get the entire schedule on the India Science Festival website, which I have also put in the chat. And you can follow us on @Science Fest on Twitter and @India Science Fest on Instagram. And you can get all the updates there as well. So thanks a lot for joining, and stay tuned and join us for the other sessions as well. Thank you so much.